Number 43 gives the polynomial f of x equals x to the fourth plus 3x squared minus 28. And it asks if the value -2 is a 0 of that polynomial. So I need to go do synthetic division, put -2 in my half box, put the coefficients of the polynomial out front. And I notice that x to the fourth has a coefficient of 1. There's not an x cubed, so I have to put a placeholder of a 0. The x squared has a coefficient of a 3. There's not an x, so I need to put another placeholder of 0. And then -28 is the constant term. To do synthetic division, I drop the 1. And next I say 1 times -2. And 1 times -2 is -2. Then I add straight down. 0 plus -2 is -2. Now I say -2 times -2, which is 4. Now I add 3 plus 4, and I get 7. Now I do 7 times -2, which is -14. And I add 0 plus -14, I get -14. Then -14 times -2 is 28. And adding -28 plus 28 gives me 0. Since my remainder was 0, -2 is a factor. Sorry, -2 is a 0 of the polynomial. Number 44 asks, is 2 plus I a 0 of this polynomial? X cubed plus 6x squared minus 14x plus 16. So again, I want to put 2 plus I in the half box. I want to put my coefficients. What are my coefficients? 1, 6, -14, and 16. 1, 6, -14, 16. And I want to do synthetic division. Dropping my 1. 1 times 2 plus I is 2 plus I. Now adding 6 plus 2 plus I is equal to 8 plus I. Multiplying 8 plus I times 2 plus I did that on the calculator over here, and I got 15 plus 10I. Now adding -14 plus 15 plus 10I gives me 1 plus 10I. Multiplying 1 plus 10I times 2 plus I did that on the calculator, and I got -8 plus 21I. Adding, I get 8 plus 21I. Notice that this is my remainder. The remainder is not 0, so no, 2 plus I is not a 0 of the polynomial f of x. For number 45, they give you the polynomial -4x to the fifth plus 3x cubed minus 5x squared minus 4, and they ask you to evaluate f of -2. So I'm going to type in, put -2 in here in my half box. My coefficients for my x to the fifth term is -4. For my x to the fourth term, it's 0. For my x cubed, it's 3. For my x squared, it's -5. For my x term, it's 0. And then the constant is -4. Drop it down. -4 times -2 is 8. 8 times -2 is -16. -13 times -2 is 26. 21 times -2 is -42. -42 times -2 is 84. Since my remainder is 80, when I synthetically divided -2 into the polynomial, then f of -2 is equal to 80. If you wanted, you could have just plugged -2 in for x. And when you typed -2 into this polynomial, you would get 80. For number 46, it says for the polynomial x cubed minus 3x squared minus 5x plus 39, they give you one zero of -3 and they tell you to find all the other zeros. This is a polynomial of degree 3, so there should be 3 zeros total. You know that one of them is -3. So I'm going to synthetically divide -3. So my coefficients are 1, -3, -5, and 39. And when I do the synthetic division, I bring down the 1. 1 times -3 is -3. Do the addition. -6 times -3 is 18. 13 times -3 is -39. So yay, my remainder is 0. That meant that -3 was indeed a 0. Now what remains is down here. So I get x squared minus 6x plus 13. To find my zeros, my remaining two zeros, I want to set that equal to 0 and solve for x. Unfortunately, it doesn't factor nicely, so I need to use my quadratic formula again. For time's sake, quadratic formula says -b plus or minus the square root of b squared minus 4 times a times c all over 2a. When I simplify under the radical, I get the square root of -16. Recall that the square root of -16, to take the negative away, I need to pull out an I. So I get the square root of 16i, which is 4i. So I get 6 plus or minus the square root of 4i all over 2. So I put both terms over 2, which simplifies to 3 plus or minus 2i. So my zeros, remember that they gave you -3, and the two remaining zeros then are 3 plus 2i and 3 minus 2i. I found all three zeros of my polynomial. For number 47, it says to factor f of x into linear factors given that k equals 6 is a 0. First thing you want to do is synthetically divide 6. Your coefficients are 1, -2, -36, and 72. 1 times 6 is 6. 4 times 6 is 24. -12 times 6 is -72. I did get a remainder of 0. With what remains here, I have x squared plus 4x minus 12. That factors to x plus 6 times x minus 2. So I can factor f knowing my zeros. And what are my zeros? My first 0 was 6, so my factor is x minus 6. And then I also have these two factors of x plus 6, x minus 2. So kind of going back and forth between factors and zeros. On the question above, it asked you to find all the zeros. If I had set this equal to 0 and solved for x, I would have x equals -6 and x equals 2. Do you see the other two zeros? I have the 0, 6, -6, and 2, which gives me the factors of, for this one, x minus 6, for this one, x minus -6, which is x plus 6, and x minus 2. Those are the three factors. For number 48, it asks you to list all the possible rational zeros of the polynomial 6x cubed plus 24x squared plus 2x minus 3. Possible rational zeros are of the form p over q, where p are factors of the constant term and q are factors of the leading coefficient. So factors of p are going to be 1 and 3. Factors of q are going to be 1, 2, 3, and 6. Again, possible rational zeros are of the form p over q. So if I put everything of p over the factor of q for 1, I get plus or minus 1, plus or minus 3. Again, I did this over that, then I did this over that. Now I want to put them all over 2. So I get plus or minus 1 over 2, and I get plus or minus 3 over 2. Now I want to put everything over 3. So I get plus or minus 1 over 3, and I get plus or minus 3 over 3, which is 1. I've already got it. I don't need to list it again. Now I want to put everything over 6. I get plus or minus 1 over 6, and I get plus or minus 3 over 6, which is plus or minus 1/2. It's already listed. So all the possible zeros are here. The possible rational zeros, sorry. 49 says to find all rational zeros and use them to factor f. Hint, use your calculator to find the first one. So when I go graph this function on my calculator, I see that it has 3 zeros. I see a 0 here at x equal -1. I see a 0 here at x equals 2. And I see a 0 here at x equals 7. So I'm going to synthetically divide and make sure that those are indeed zeros. So the first one I saw was -1. So my coefficients are 1, -8, 5, and 14. When I do my synthetic division, I do get a 0 remainder. So now I want to do synthetic division again with what's remaining with my 0 of x equals 2. When I do the synthetic division, I get a 0 remainder. And one more time to check and make sure that that 0 of x equals 7, 1 times 7, I do get a remainder of 0. Okay, so yes, I did verify that x equal -1, 2, and 7 are all zeros. So x equals -1, x equals 2, and x equals 7 are zeros. Those are my 3 zeros of that polynomial. Now if I want to write that polynomial in factored form, I do x minus -1, so x plus 1. I do x minus 2, and I do x minus 7. For number 50, I want to find a polynomial of degree 3 with real coefficients that satisfies the given conditions. They give you the 3 zeros of -3, 2, and 8. And they also tell you that p of 1 has to be 28. So my polynomial, I'm going to write it as a times x minus -3 times x minus 2 times x minus 8. This a out front is going to come into play in a few minutes when we have to have the condition p of 1 equals 28. So just leave it alone for a minute, and I'm going to FOIL these two things, these two binomials. So I have a times x plus 3 times x squared minus 10x plus 16. Now I want to multiply this binomial by that trinomial, and for time's sake I'm not going to rewrite it. This is what you get. Now I need to collect like terms, and I get x cubed. Now the x squared terms, I get minus 10x squared plus 3x squared, so that's minus 7x squared. For my x terms, I get 16x minus 30x, which gives me minus 14x. And then my constant term is plus 48. Okay, now I need to solve for a when I plug 1 in for x and set it equal to 28. So my polynomial is equal to 28 when x is equal to 1. One minus 7 minus 14 plus 48 is equal to 28. When I divide both sides by 28, I get a equals 1. So my polynomial is going to be p of x equals 1 times x cubed minus 7x squared minus 14x plus 48.